So today we'll more focused on electric vehicle, focusing on BLDC motor. Okay, so we're going to start about it, but prior to that, we need to understood exploring the backbone of EV propulsion. I'll give the tagline that exploring the backbone of EV propulsion. Why it is actually exploring the backbone of EV propulsion? Because in the electric vehicle, the propulsion unit, the traction unit is actually been controlled by the motor itself. That's why we are saying motor is nothing but the backbone of EV propulsion. If motor will be not there, then ultimately electric vehicle won't run. We'll provide the power, but to whom we are going to provide the power, we don't know. Right. So motor is a very primary thing which is actually dedicated for the propulsion system. But only motor is not responsible for the propulsion. There are a lot of other components connected in between such that the propulsion had been conveniently done or it is being optimizedly done. That is not that we'll give for example, if I give a speed, let us suppose 10 kilometer per hour, 20 kilometer per hour, 30 kilometer per hour, 40, 50, whatever the speed I'll try to drive my vehicle. Okay, I want that my motor should rotate at that speed. But if I don't connect controller, if I'll only provide from battery to the motor, I won't control that controlling, right? I won't control that speed. So to make the speed control, I wanted a control unit. So complete control unit, motor, everything comes under the propulsion unit, but still motor is the backbone of the EV propulsion, because ultimately if motor will be not there, the or tires won't be able to rotate, right? So over here we are going to as this is the demo session, over here we're going to focus on one kind of motor, which is the BLDC motor, or we can call it as the brushless DC motor or brushless direct current motor. Okay, so what are the things we're going to cover in the content? First we're going to cover what are the different introduction, what exactly the electric motor was, right? Prior to that we'll learn about what is exactly the EV was, how EV is working, right? Then we're going to understand what are the BLDC motors basics. Then we're going to understood its working principle. Then we're going to understood the application of the BLDC motor, where we are actually using the BLDC motor. Then we're going to look on the advantages of the BLDC motor. Then we're going to look over the challenges of the BLDC motor, right? If there is certain technology which has certain advantages, so definitely the technology has certain disadvantages, or to implement that technology, we are going to face some challenges. We're going to understood the challenges. But as an engineer, our work is to reduce those challenges. Our work is to innovate something such that we can reduce those challenges. Then we can understood the role of BLDC motor in the EV revolution. Then we're going to understood the future trend and innovation in terms of the BLDC motor as well as the motor technologies. Okay, because electric vehicle is nothing but a developing thing. It is a developing technology. So it is developing. It is not that it is already developed or we are reading it. No, it is developing, continuously developing. Okay. So first of all, I wanted to learn from you that what if once terms comes, right, electric vehicle. So what do you actually understood by the term electric vehicle? Can anyone let me know? What do you understood by the term when the term come electric vehicle? What do you understood by it? Anyone, guys? When the term and electric vehicle comes into account, what do you understood by the electric vehicle? Can you please let me know if you have certain ideas? Okay, fine. No idea. No one have no ideas. So I'll let you know what exactly the electric vehicle was. Okay. When I'm talking about an electric vehicle, electric vehicle is something which is run on the electricity. Okay, like IC engine vehicle, which is run on the petrol and diesel and gasoline, okay, on the fossil fuels, right? Electric vehicle is something which is never run on fossil fuels, it will run on electricity. And that electricity is generated by the battery. Okay, that electricity is stored in the battery and then it is being consumed, it is being utilized to power the motor such that the motor will rotate. Once the motor will rotate, ultimately the propulsion unit will rotate, ultimately your tire will rotate, ultimately your vehicle runs. But here in the process of running your vehicle, you don't need to consume any petrol, diesel, gasoline to run your vehicle. That's why it is nothing but called as the electric vehicle, because it is purely run on the electricity. That's why it is nothing but called as the electric vehicle. So electric vehicle is a vehicle which is actually powered by an electric battery but propelled by an electric motor. Okay, so here the propelled terms comes into account. Here the Okay, less pollution for our environment. Okay, fine, less pollution for our environment is being there. So that is actually called an electric vehicle. But when I'm talking about an IC engine vehicle or the conventional vehicle which we are actually running or which we are actually driving, that is actually powered by an engine, not by an motor, not by an battery. That is actually powered by an engine. The complete vehicle propulsion unit is from engine to differential to gears. All those systems connection has been done, and ultimately your tire is being rotated. Ultimately your wheels is being rotating in nature, right? That is what the conventional vehicle working is all about. Conventional vehicle propulsion unit, conventional vehicle power transfer is different from the electric vehicle power transfer. Okay, concept remains same. We have to transfer the power from the generation to the transmission, to the final transmission, that is up to the wheels, right? But the concept remains same, right? Apart from that, the electric vehicle is environment friendly. When the IC engine vehicle or when the gasoline based power vehicles will going to propel your vehicle, they're going to emit the pollutant like carbon dioxide, like nitrous oxide, like carbon monoxide, various gases. They're going to pollute it to the environment. They will going to pollute our environment in turn as well, right? Ultimately, when the battery vehicle will be going to run, it will not going to pollute any kind of hazardous gases to the environment. It will not have any tailpipe emission. I'm again repeating this term, tailpipe emission. There will be no tailpipe emission is being there in an electric vehicle, right? Tailpipe emission means nothing. If the electric vehicle will run, you will ensure, you will completely forget that there will be some pollution will be going to happen to the environment. It will be the pollution free vehicle. Yeah. When the vehicle is running, it is pollution free. But when the vehicle is manufacturing, some amount of pollution is actually happening in the environment. But it is on the manufacturing stage. Okay. Manufacturing is done in very lesser times, right? Nowadays, because of the use of because of the use of heaviest technologies, right? Manufacturing is done in very lesser time. Okay. But the majority of the pollution in a vehicle industry is being done when the vehicle is in the running mode. When the vehicle, you are actually propelling the vehicle, at that time the majority of the pollution is being happening, right? So electric vehicle pollution in the time of its running is very low. If I'm talking about the examples of the electric vehicle, then it might be battery electric vehicle, which is purely run on the battery, which is purely run on the electricity. Then HEV, which is hybrid electric vehicle, which is purely run on the, which is not purely run on the battery. It is run on the combination of engine plus battery. Just a second, guys. Let me write something. Yeah. Well, if I'm talking about BEV, it is purely run on electric mode. If I'm talking about HEV, it is purely run on engine plus battery. If I'm talking about PHEV, plug-in hybrid electric vehicle, it will be run on the engine plus battery. But here in HEV, you cannot charge the battery from the external source. What do you mean by external source? Like we are charging our mobile phones from the external source. Over in HEV, we cannot charge this battery from the external source. We can charge our battery in electric vehicle in external source, but in hybrid electric vehicle, we can't charge our battery from the external source. But in PHEV, we can charge our vehicle from the external source. But the hybrid electric vehicle, P-hybrid electric vehicle concept remains same. They both are operating by engine and battery both. They are both powered by engine and battery. But but again, PHEV can be charged from the external source. HEV can't be charged from the external source, right? So these are the types of the electric vehicle. Probably if you are going forward to the section of the basic electric vehicle lectures, over there you're going to understood what actually the electric vehicle was, how they are actually operating, what are the different types of the electric vehicle, and related technologies in the further moving ahead, right? So electric vehicle need to be charged. Likewise, your fuel will be ended. Then you went to the fuel station and over there you are refueling your fuel or your tank. Here the battery will be discharged and you have to recharge the battery. Okay. Then you have understood what are the major component of the electric vehicle. Before understanding about the complete electric vehicle, we should understood how the electric vehicle is actually working. So electric vehicle is working because of some major component is being attached to it. What are the different major component attached to the electric vehicle? One is battery, another one is motor, then it is battery management system, which is solely responsible for the battery we can call it as a battery brain, in fact, right? It is wholly responsible for the management of complete battery pack. If this BMS is not there, then your battery pack won't be managed properly. Then if I'm talking about the motor is actually something which is powered by an battery which will propel and ultimately it will going to rotate your tires, right? Then we have controllers. What is the controller function? It will control the amount of current or power flow to the motor. Okay, so by controlling the amount of current and power flow to the motor, it will actually control the speed of the motor. When we are actually operating, while increasing the speed, we are actually pressing our accelerator paddles. When we are actually pressing our accelerator paddle, what is actually happen? How that signals? We had pressed it mechanically, but this battery is an electrical component, motor is an electrical component, right? How they are going to understood that how much speed I had given mechanically? So there is a sensors. That sensors will going to transmit the data to the controller, and that controller based on that data control the amount of power and current flow from the battery to the motor, and this is how controller control the speed of the motor, and that is how the complete electric vehicle works. Apart from that, there are a lot of accessories to connected in the electric vehicle, like DC-DC converter, such that it can power the other components. So here it was connected, it was inverter. Sorry, it is not DC-DC converter, it is inverter. It is actually there to convert your DC power to the AC, alternating current to the direct current. Everybody knows that in in your homes, right? Inverter is being placed. It is actually storing the DC power when your power is being cut, or you are disconnected your power, or because of some fault, the power is being not there. So inverter is supplying your power to your homes. So inverter stored the DC, then the inverter circuit, it is actually passing the AC, and ultimately you are getting the alternating current. Then here all the transmission system things is being attached through which the motor is being connected. Over here the SMPS charger is being there, vehicle thermal management system and battery thermal management system is there, DC-DC converter is there. Apart from that, there are a lot of other component is being also used, like your lights, horns. Apart from that, other electronics rectifiers is being used, other various electronics component is being used. In fact, a lot of controllers is being used, ADAS systems is being used, embedded systems is being used. All these things is being used. All these things is being used such that it will make your vehicle, it will make your vehicle smooth such that while running, for example. But these are something which is very very important in terms of your propulsion unit, right? Your complete vehicle will run if your battery and motor and controller will work properly. Okay, okay, if these three work properly, ultimately your vehicle will run. Okay, so these three are responsible for complete propulsion of your motors only, of your vehicle only, right? Rest other thing like inverter is not that important. Okay, DC-DC converter is not that important. Yeah, charger is there, but again, you have to charge your battery. But in order to propel your vehicle, battery, controller, and motor is being there. That's why they are nothing but called as the powertrain of the vehicles, right? So these are the major components which we need to learn. But what is the focus in this demonstration? We have to focus on the motor. So multiple types of motor is being used in an electric vehicle, but here we are only focusing on the single type of motor, which is BLDC motor or brushless DC motor. Now I'm going to study how the electric vehicle works. Okay, would you see the animations? Everyone, would you see the animations? Second, what are the messages, sir? Which type of supply we use to run the electric vehicle, AC and DC? It was Rahul. It was depend upon the motors. If I'll use the alternating current motor, I want AC supply. If I use the direct current motor, I want a DC supply. Okay. If I want my DC need to be converted to the AC, I'll use the inverter. If I want my AC in while in an electric vehicle we can only store the DC, right? Because we had the battery. But again we have to decide that which motor we are actually using in our vehicle to propel, right? If it was an induction motor or if it was a permanent magnet synchronous motor, we will use the AC. If it was a BLDC motor, we will use the DC. It was depend upon AC, it will depend upon the type of motor we had used. But yes, electric vehicle can be propelled by both AC as well as DC. I guess Rahul Babu had cleared it. Fine. Everybody able to see the animation? just a second, clear. Okay, just a second. Yeah, can anybody let me know what is actually happening over here? What is this? This is accelerating, right? Once we are accelerating our vehicles, what will happen? This acceleration, because here because here what we are doing, we are actually pressing the accelerator. What we are doing, we are actually pressing the accelerator mechanically, right? Here we are not going to give an electrical signal from the outside, from the user end, from the driver end. Driver only presses the accelerator, that means it gives some mechanical input. So but controller, motors, battery, they are the electrical equipment, right? They want some electrical signals to be work on. So there must be something which convert this mechanical signal to the electrical system signals, right? So within this accelerator, there will be the sensors connect. Basically, those sensors are called the Hall effect sensors. This sensors senses the position of your accelerator, whether it is down or up. Based on that position, they will going to send the data to the controller. And in the controller, there was already a microcontroller or microprocessor is being embedded. That microprocessor or a microcontroller is acting as a brain of your controller, right? That controller will process that data, and based on that input, it is actually controlling the power flow from the battery to the motor. Okay, and then the power flow from the battery to the motor is being controlled. Let's say if I'm pressing the accelerator, that means I'm increasing the speed of the vehicle. Hall effect sensors senses that, send its data to the controller. Controller processes it, understand it, and control the power flow from the battery to the motor. And from motor, the tires is being controlled, the tires is being rotated. I guess everyone is getting up to this. This is a very simple connections, very simple thing that an electric vehicle works in just. Right. Now, in a complete EV courses, you're going to understood how each and every component works, how to select controller, how to select battery, how to select motor, which motor should be focus on, which motor should we take. All this thing we need to be learned in the upcoming classes, in the upcoming EV sessions. So moving forward, once the motor comes into your account, so here we're going to understood the BLDC motor, but prior to that motor, when the motor comes into account, I told you motor is something which is actually responsible for the propulsion. Okay, generally in our basics classes, we had learned that motor is something that is actually converting your electrical energy to the mechanical energy. You are giving the electrical energy to the motor's input, and at the output, you are getting the mechanical energy, and you wanted to transfer that mechanical energy to whatever source you wanted to, it will be transferred to that source, right? So motor are being used for various purpose, not only in an electric vehicle, from the industrial level, from your home applications up to your electric vehicle, motors is used everywhere. Okay, inside right now in the day-to-day life activity, like your brushes is also consisting of motors, right? The electric brushes, right? Okay, all this thing consisting of the motors, from the propulsion, from basic home needs, everywhere you are finding the motors, right? So we all know, we all from our childhood had understood what the motor was. Motors are ranging from normal volts to normal watts to the 1,000 megawatts as well, or 100 megawatts as well. It can able to generate. The same motor can be acting as a generator as well. What is the generator? Generator work is to convert the mechanical energy into the electrical energy. If you rotate the rotor, right, ultimately at the input section of the motor, you'll getting some electric current, right? So we use those concept in the regenerative braking of the electric vehicle. What is the regenerative braking? That when we are braking our vehicle, at that time our motor is not acting as a motor, it will acting as a generator and generate the electricity. That electricity is further being stored in the battery such that we can use that for our future references. So regenerative braking is a very important phenomenon that is actually used in majority of the vehicle for energizing or for charging the battery, or such that it will be energy efficient, right? So if I'm talking about electric motor classification, right now I guess who had asked me, yeah, Rahul Babu is asking me about, sir, what kind of current we're going to use in the electric vehicle, whether it is AC or a DC, right? I told you about it was depend upon the motor. If it was the AC motor, it will going to work on the AC. If it was a DC motor, it will going to work on the DC. If it was the reluctance motor, then also it will going to work on the AC. But here the AC motor and reluctance motor have a lot of difference in between, that the reluctance motor is working on the principle of reluctance. Yeah, any doubt? Can we get the PDF as I joined late? Yeah, you will get the PPTs in terms of PDF. I'll share it to you, Shad Hassan. No issues. Okay, don't worry. I'll share it to you. Okay. Then, if I'm talking about the DC motor, AC motor, and reluctance. Okay, welcome, Shad. Okay, reluctance motor is work on design. Their AC reluctance motor will also work on the AC supply, but there is certain design constraint in the reluctance motor, right? Reluctance is the property of the material such that it can oppose the magnetic field, right? Like resistance in the electric current or in electric field. Likewise, in magnetic field, there was reluctance, right? So this is the small difference between resistance and the reluctance. Here are more focus on the brushless DC motor. But prior to that, we need to understood what is actually the brushed DC motor, right? But prior to that, please understood what is the history of the BLDC motor when it was invented. Initially we are not using any BLDC motor over there. We are using the brushed DC motor, right? But we all know brushed DC motor means that contain the brushes, that contain the carbon brushes. With time, that carbon brushes will be degraded. Okay, and the carbon collection is being happening in the DC motors initially, right? So for the large application, when the process is being there, a lot of friction will be there and heat will be generated. Ultimately, it will going to reduce the efficiency of our motors. If motors efficiency will be reduced, it will affect the electric vehicle propulsion as well. So we want some alternatives. So research is being going happens, and ultimately on 1960s and 1970s around, BLDC motor has been emerged, right? It was first practically implemented by these two scientists, right? If I mention these two scientists, T.G. Wilson and P.H. Tirke in 1962 only, right? When they had been made the particular BLDC motor practically, they had been documented it first, right? They had been tested it in the documents and various other, parameters they had checked to make the BLDC motor. Then they had practically made it, right? BLDC motor is consisting of the permanent magnet, right? I'll make you understood what is permanent magnet, what is electromagnet. But BLDC motor is actually using the permanent magnet, which is ultimately made up of a rare earth element. What is rare earth element? Can anybody let me know what is rare earth element? Okay, fine. Okay, rare earth element is something which is, the name suggests, which is very rare in the environment or earth crust, right? So if you went to the periodic tables, right? Exactly, lanthanide elements. These are called the rare earth elements, right? Lanthanide, which contain 15 elements, right? Scandium, erythrium, right? These are something called as the rare earth element. Exactly, 17 chemical element which are rare earth. Right. Okay. So this rare earth material is actually used to make the permanent magnet of the BLDC motor, right? Like neodymium. Okay. So the rare earth magnet is being made at the late 20th century. If I'm talking about late 20th century, that then it means from 1950 onwards, this rare earth element is being excavated from the earth crust. And then only the BLDC motors comes into account, because BLDC motor is using a permanent magnet, and that permanent magnet is actually using the rare earth element like neodymium, right? So that neodymium, scandium, all those things are made are actually used to make the permanent magnet. Neodymium is only just one compound which is used to make the permanent magnet, right? So again, the rare earth element excavated from the ground, ultimately the BLDC motor is being come into account. Once the BLDC motor come into account, which don't contain any brushes, so there will be no chances of the frictional loss. There will be nothing will be there. First BLDC motor is used in the application where we are using. It is used in the aerospace applications, right? Such as actuators in the aircraft, such as you know in actuators in the aircraft. Apart from that, some motoring actions in the aircraft, it is actually being done by the a BLDC motor initially when it was actually invented. So BLDC first is being implemented in the aircraft. Then it is being from the aircraft came to the industrial level, then to the computer cooling fan system, then for the precision robotics, then for the home remedies applications, then for the electric vehicle attend. If I'm talking about an electric vehicle, there is no well documented thing that who invented the BLDC motor for the electric vehicle. There will be no such documents is being there. But some companies which is actually use the electric motors, BLDC motor in their vehicle, they are consisting of General Motors EV1, which is being invented in 90, which is being manufactured, starting in manufacture and launched in the year between 1996 to 1999. They're primarily using the induction motor, but also explored the usage of the BLDC motor in the vehicle. And also they had used the BLDC motor in the prototype as well. Then if I'm talking about in India, Hero was the first company which is being founded in 2007. They are actually using the BLDC motor in the scooter models. That is called the hub motor. They're initially using it, right? Then if I'm talking about other companies which is using earlier, BLDC motor, that was Mahindra E Alpha Mini Electric Rickshaw. If you have ever heard about this rickshaw, it's being launched in 2017. Over there, this particular thing, the BLDC motor is being used in a very huge amount. Then someone is saying, some reports claiming that Tata Nano EV, which is now to be launched, they are actually using the BLDC motor in the prototype mode. But as of the Tata specification, Nano is not using the BLDC motor; they are using the PMSM motor. But Yana, during the prototyping mode, during the designing mode, that even tested it with the help of the BLDC motor. Okay, so BLDC motor stand for brushless direct current motors. Okay, brushless direct current motors are 75% to 80% more efficient, 75% to 80% more efficient than the conventional brushed motors. Right? Conventional brushed motor, I had already told you, conventional brushed motor had the brush in it. That brush with respect to time is being going to be friction, because we are providing the supply to the conventional motor via brushes. When the commutator rotate, it will going to be having a friction. Likewise, this thing will be happen. This brushes is being attached to this commutator ring. Okay, so what had happened? Let us suppose this is the conductor. This is the conductor. We are going to provide the supply to these brushes. So the conductor will rotate in this direction, the conductor will rotate, but this brush will never rotate. So how the supply will be ensured? This commutator ring will be going to friction, will going to slip over this brush, over this brush, and ultimately they're going to get the supply. So with time, when in the higher application, if this friction will be more, and we all know if friction will be more, they're going to generate heat. They're going to generate heat. If heat will be generated, ultimately what will happen? Your losses will be high. If losses will be high, motor will be less efficient. What is less efficient? If I had provide him 5 volt, in the heat 2 volt is being losses, and actually at the output I'm getting 3 volt. Okay. Heat is generated and heat will be generated and efficiency will be low. Yeah, exactly. Due to brushes, that is actually happening, right? All of you getting, guys? Okay. If I'm talking about the construction of the BLDC motor is being looking like this. Everybody, if you heard about drone is basically using the BLDC motor, brushless DC motors, right? We all know the motor is consisting of two parts. One is stator, another one is rotor. Stator is the stationary part, rotor is the rotating part, right? Stator is the stationary part, rotor is the rotating part. So in the motor, the everything which is stationary in nature, which is not movable, that is nothing but called as the stator. In the complete motor, which is rotating in nature, which is movable, that is nothing but called as the rotor. Right. So if I'm talking about the stator, it is made up of some different element. If I'm talking about the stator, just a second, guys. If I'm talking about the stator is made up of stacked silicon steel. What is stacked silicon steel? It was made up of the steels. It was made up of the silicon. It was made up of silicon because to reduce the high, because silicon has the high permeability. Permeability high means it will allow more magnetic field or more flux to pass through it. Okay, if it was allow less flux to pass through it, then magnetic field which was created will be less. Ultimately, rotor rotation speed will be less. So high permeability, that will allow more magnetic flux to pass through it. If it will allow more magnetic flux, which is represented by phi, to pass through it, ultimately the magnetic field strength of that material will be high. What is this stacking? Stacking is nothing but this stator is not made up of a single material called silicon. First, the silicon, likewise silicon steel is being there, right? Likewise silicon steel is being there. Then again the lamination is being done. Apart from that, again a silicon stacking is being conducted. Then again the lamination is being done. Then again the silicon stacking is being conducted. Likewise. Okay, so this is not this stator, you are watching this in the front view, but actually this is not is made up of the single metal, single silicon steel. Instead of that, it was made up of layers of silicon steels. Why this layers of silicon steel with lamination is being done? To reduce the eddy current loss. What this eddy current loss is? What this eddy current loss is? What is this eddy current losses? Here what is happening? We are going to provide three-phase supply to the stator. We're going to provide three-phase supply to the stator. So if we're going to provide three-phase supply to the stator, so in the stator there will be the stator winding. So if in the stator there will be the stator winding, and if we are providing three-phase supply to the stator, ultimately what will happen? The electricity will be generated. That electricity will be going to induce the current in the coils, right? And ultimately, if more number of electricity comes into the account, ultimately when current will be generated, that means electron will be moved continuously and continuously, that will going to generate the heat. So if this coil is generating the electricity, this coil is going to develop the electricity, it will going to generate the magnetic field. It will going to generate the magnetic field. And on that magnetic field, the rotor will rotate. But if this coil is conducting electricity, that means it will going to emit the heat for the long time. If we are going to run the electric motor, right? Let us suppose we are going to run the electric motor at high speed. So high number of electricity will be going to pass through the stator winding. So it will generate more and more heat. If that heat will be generated, ultimately whatever, if the heat will be more, that heat will be not properly dissipated, then ultimately it will going to be loose. It will going to be acting as a loss for us, right? So to dissipate the heat, we are actually making it stacked silicon steel. Lamination is being there, right? That heat dissipation is because of the current. That's why that is nothing but called as the eddy current losses. Instead of thermal losses, we are calling it as the eddy current losses, right? That's why stacked laminated stator core is being made up of, right? If I'm talking about what is core and what is the outer portion of the stator, okay, so here, if you're watching it here, this green color part is nothing but called as the yoke. Okay, what is stator? Except this is nothing but act as a rotor. This is nothing but act as a rotor. But except this rotor, whatever else remain, that is nothing but called as the stator. The outside part is the yoke, the inner part is the stator core, right? And that core had a lot of slots in it, like this is A slots, B slots, C slot, A dash, B dash, C dash. These slots will be there, right? And within these slots, the winding has been passed, right? Whatever the stator winding, whatever the coil arrangement, we had been whenever we had been able to heard, like my motor winding is being cut, my motor winding is being damaged. Okay, so where that actual winding is being done, it is being done in this slots only. This slots is for magnetic windings. I guess you are getting up to the stator, right? The winding is made up of the copper material. Okay, basically the copper material winding is being done. If I'm talking about the rotor is made up of the permanent magnet. Okay, that is why I told you that permanent magnet led to the innovation of the BLDC motor, because the rotor is made up of the permanent magnet. Various material are being used, various rare earth material is being used, like selenium, cobalt, neodymium, ferrite, boron materials are being used to make this permanent magnet, right? So let us suppose we are using a neodymium material to make the permanent magnet. Now, can anybody let me know what is exactly the permanent magnet and what is exactly the electromagnet? Can anybody let me know? Anyone from you? What is the permanent magnet and what is the electromagnet? Anyone, guys? Permanent magnet and electromagnet. Let me write it. Permanent magnet and electromagnet. Permanent magnet is nothing but which is permanent in nature. Electromagnet is nothing but which is not permanent in nature. For example, let us suppose I have a permanent magnet and I have a north and south pole created over here. I would, yeah, okay, anybody have any answer? Electric magnet giving a supply to the conductor. Exactly. Whatever you are telling, it is a electromagnet, right? Right. So what is permanent magnet was? Permanent magnet was something, let us suppose this is a permanent magnet. So it was already a north pole and already a south pole. We cannot change the pole from here to here, here to here. That means we cannot make it north, we cannot make it south. We cannot make it like this. The poles remain fixed. We cannot change the poles in the permanent magnet as it was permanent in nature because they are found in the rare earth material. This pole has been created because of so nature's process. So we cannot change it, right? Then whatever the, so this pole will be there, then definitely there must be the magnetic field. Every magnet had its own magnetic field. And in our lower classes, we had heard about, we had learned that in our BTech times or in 12th time or in ITI or diploma times, we had heard that magnetic field is always passing from north to south externally, and internally they are passing from south to north. Okay, any doubts? Permanent magnet, we don't give supply to the material, act as a magnet. Great, exactly. The same thing was there, right? So what had happened? We cannot change this magnetic field intensity as well. Likewise, let us suppose this magnetic field intensity is 5 decibel. So it always remain 5 decibel. I cannot change this to 4. I cannot change it to 6. Okay. Yes, I can change it, but again, it was a very rigorous process, very industrial process. So in a complete vehicle, we cannot give the industrial process, right? In a small vehicle, we cannot tolerate the industrial process, right? Various things by heating or something, we are actually reducing the magnetic field intensity or something else we are doing. But generally, we cannot reduce the magnetic field intensity of the magnet. Okay, up to this, everyone is getting, guys? What is this Hall effect sensor? We're going to learn about it when we're going to understand the working principle of the BLDC motor, right? So now, if I told you about how the BLDC motor works, yeah, let me zoom it over here, right? Then I can make you understood how the things will be there, right? So let us suppose this is the motor arrangement. I guess all you are able to see my screen, right? See these figures where I'm going to mark it, right? So let us suppose this is magnet. Everybody know this north pole will going to attract south pole and south pole will going to in turn attract the north pole. That means like pole repel and unlike pole attract. I guess this concept everybody had already know, right? Star connected, sir, why we using only star connected? Oh, you're asking about star and delta connection. That is being done in the alternate AC motors. That is not being done in the DC motor. That is being done in the AC motors. In DC motors, there will be no star connection and delta connection is being done. Okay, in DC motors, we are using the delta connections as alternate. AC motors, we are going to connect the star connection majority, but we cannot say it is not being connected in delta. We are also connecting in delta, but it is again depend upon various factors, right? So I'll let you know when we're going to study the alternating current motors over there. We're going to let you know. I'll going to let you know why it was only majority is being star connected and not more is being delta connected, right? It was there, delta connection is also been there, but we are not using it more, right? We can, it is possible to connect the delta connection in the motor and we can use it out. Are you getting, Rahul? But in DC motors, we are not using star and delta connections. Okay, here we are using the lap and wave windings. Okay, yeah, everybody understood this. Like poles attract each other, unlike poles repel. Unlike poles attract each other, like poles repel each other. Right. So it was a north. It was only being attracted by the south. If it north will be there, they're going to repel each other. Right. These are the things. These are the small things that we had been already know from our small classes. Right. So this rotor is a permanent magnet. Let us suppose this A, B, C, D are my phase, are my coil arrangement. I am going to give three-phase supply to this particular coil arrangement. What I am going to give it three-phase supply to this coil arrangement. So what three-phase supply will going to do? A, B, C, D, four coils is being there, right? So what this three-phase supply will going to do? First, let us suppose we have A, B, C, D, and our rotor position was like this. and I wanted to rotate my rotor in this direction, So if I wanted to rotate my rotor in this direction, in clockwise direction, so what do you think? The B need to be energized in which way to attract this south pole? What I need to be lighted over here? Whether I'll write north or south over here? Anyone, guys? Whether I'll write here north or south?
South.
North. Why south? If I'll write south here, if I'll write south, north, great, north. Yeah, it will write north here. Just a second. If I'll write south here, what will happen? This was the like pole. So like pole will repel each other. That means it will push. So if it will push this, it will rotate in this direction, right? So instead of south pole, I'll going to energize it in the north pole. I'll going to energize in the north pole. So this is nothing but the north pole for me. So this north pole is going to attract the south pole. This north pole will have to move over here to make the complete permanent magnet to rotate in a clockwise direction. So this B dash will be acting as a south pole, right? So what is an electromagnet? Now just do let me know what is an electromagnet. Let us suppose this is the coil, this is something, right? If I am connecting this coil with a battery, this will acting as a north, this will acting as a south. Now I'll ask you that change these poles. I want that my connection should be north here and south here. So what you will do? You will do simply, you will change the polarity of the battery. Then this side will be north, this side will be south. So you are just changing, by just changing the polarity of the battery, you can change the poles also. You can change the direction of the poles also by just increasing or decreasing the supply voltage. Let us suppose this is 5 volt supply is given. If I am connecting the 9 volt supply, I can control the intensity of the magnetic field as well, right? So in electromagnet, I can control the directions of the pole. In electromagnet, I can control the intensity of the magnetic field as well, right? So this B dash is nothing but the coil. We are providing him with the 3-phase supply. So if it was a north and south, so the supply is positive here and negative here, right? Likewise, consider, right? Then further I have to rotate it to this way. So what I need to be energized to this north, and this must be south. Likewise, this is north and this must be south, right? Further I have to rotate in this way. So what we will do? What I will do? This will be north and this will be south. Further I have to rotate, right? So now after the 180-degree rotation, just a second, why the pen is not working? Yeah, after the 180-degree rotation, when the north pole is over here and south pole is over here in this way. Now what do you think? What must be the B energization? How I'll energize the P and B dash? What I should write over here in B and what I should write here in B dash? What I'll write here? If I'll write north, what will happen? It will repel or attract? I'll to keep the continuation in a clockwise direction. Attract, right? Attract. If I'll write it here north, it will attract this particular north pole. So it will repel, right? Wait. Yeah. Okay. It will repel, right? So what exactly I need to be energized over here? I need to be energized with the south pole and here in the north pole. Okay. So just do let me know. Initially, the B is being energized as north pole here and south pole here. Now the B is being energized. Now the B is being energized here as, just a second. Yeah, now initially what had happened, the north pole is being formed here, the south pole is being formed here. When the rotor rotate 180-degree, after that 180-degree, this B is acting as a south pole and this B dash is acting as a north pole. So what you will have to do, you have to provide them the supply, but initially with positive here and negative here, but after 180-degree rotation, you need to change the polarity, right? So this polarity need to be changed. Okay, so now you have a question, sir. The rotor is rotating in a specific direction, and based on the rotor position, the coils are actually energizing. The rotor is rotating, and based on the rotor position, the coils is actually energizing. So who will going to energize the coil? Who will know that which direction the rotor is there, right? So for that, we are actually using a sensors in the BLDC motor. That sensor is known as Hall effect sensors. This Hall effect sensors work as to detect the direction of the rotor, detect the position of the rotor. Based on the rotor position, it will going to energize the coil. Based on the rotor position, it will going to energize the coil. Okay, so how it will going to energize the coil? It will detect the rotor's position and it will give the data. It will give the signal to the motor. It will give signal to the controller. Sorry, it will give signal to the controller. What the Hall effect sensor will do? It will sense that motor in this motor are in this direction. So it need to be energized. It need to be rotated in this direction. So we need to be energize the D and D dash with north and south pole. Okay, so this motor's position will be determined by the Hall effect sensor, and whatever the motor position it will sense, it will send the data to the controller, and the controller will in turn take the action to energize the coils. And once the coil is being energized, the motor is being run. So here, without the presence of any brushes, we had given the supply or we had energized the coil. Apart from that, we had rotated the rotors as well. That's why the BLDC motor is nothing but called as the electronically commutated DC motor. Electronically commutated DC motor, right? Because of this functionality of the BLDC motor, because they are being not commutated. Commutation means they are being not energized by the brush. Instead of brushes, they are being energized by the combination of Hall effect sensor and the controller. That's why they are, and combination of Hall effect sensor and the controller, they all are the electronic components. That's why they are called as electronically commutated DC motors. If it is south, it will attract. Okay. So everybody understood up to this how the BLDC motor is going to work. In the actual session, in the EV classes, we're going to understood it in very depth. How this will be done, how the Hall effect sensor will be going to sense that position will be that the position will be that, right? We're going to understood each and everything in a very depth. But till now, everybody had understood. Guys, Arga, Jagannath, Rahul Babu, Shad. Everyone is understood, guys?
Yes, sir.
Great. Okay, then we are going to understood what are the different applications of the BLDC motors. Okay, if I'm talking about the applications, it is being majoritarily being used in the two-wheelers. Okay, in four-wheelers, it is being used in the bogies or it will be used in the golf carts. Okay, but it is being majoritarily being used in the two-wheelers. Nowadays, also Ather 450X and Hero models are using the BLDC in runner and outrunner motor. Okay, so BLDC motors are basically classified on their construction of two types. What is that? One is in runner, another one is outrunner. What is in runner? In runner means the inner part will be going to rotate and outer part will be the acting as a stator. Outer part is stator and inner part is rotor, right? But in the outrunner motor, what will happen? The outer part is rotor, but the inner part is stator. Inner part is stator and the outer part is rotor. So the outer part will be going to rotate. Inner part will be always remain stationary. Like this motor, you will understood that the outer part, this part will be going to rotate. So what we can innovate, we can directly embedded the tire over this motor. So if outer part will be rotated, then the tires will be automatically rotated. And we are fixing these tires on the back of the wheels, on the rear wheels. Ultimately, your vehicle will move. In the in-runner motor, what will happen? Your inner part will be rotated, and from that inner part, the belt drive system is being connected to your vehicle wheels like this. So your motor will be somewhere here. From that, the chain system is being connected to your wheels. And once this motor will rotate, the back wheels will be going to rotate. Once the back wheel going to rotate, your vehicle will run. Okay, so this is majoritarily being used. This is not being used more. This is not being used more. Okay, the vehicle which is using this hub motor, they are very cost effective vehicle. Why? Because they are not much costlier. Why? Because this hub motor was cheaper compared to the mid drive. This in runner motor is also known as the mid drive motor, right? The BLDC motor, the outrunner motor is much cost effective than the in runner motor. Apart from that, the disadvantages of this outrunner motor was what? This tire is always being exposed to the stress and strain. If there was a dump hole is been coming on the road, this tire will be going to have the lot of stress. The force is acting on this tires only. It can damage your motors as well. During the rainy season, it must happen that the water can be percolate inside the motor and the windings can be shorted. So because of higher maintenance, this motor is not being majority being used by the various other vehicles. But it is being used in some vehicles, which is generally used for the low distance travel. But one advantage of the outer runner motor is it is directly transferring the power to the tires. There is no other supplements. But here the mid-drive motor is transferring to the wheels via the chain system. First, the force is being transferred to the chain. From the chain, it is being transferred to the wheels. So here friction losses is being there and heat losses is being there. Because of this friction and heat losses, ultimately the vehicle will be comes into lower efficiency. So efficiency of this outrunner motor is high, but again it was the cost effective as well. But again it was very maintenance, highly maintenance. It was low in maintenance, but efficiency compared to the outrunner motor is much high, right? Then if I'm talking about Ola S1 is using hub motors as well, right? Then Ather 450X Revolt is actually using the hub motors too, right? And Golf Cart is also using the hub motors too. Okay, some of the vehicles, but nowadays Revolt, whatever it is actually, inventing that is actually using the mid-drive motor. They are not more using the hub motor; they are using the mid-drive motors majority. Ola uses initially the outrunner motor, but now they had been converted themselves into in-runner motor. But now they are not using the BLDC motors also, they are using the PMSM motor, AC motors they are using. Getting, guys? Initial models of the Ola uses this outrunner. I guess Ola Model S is using. Getting? Can we proceed further?
Yes.
Okay. What are the advantages of the BLDC motor? First, it was highly efficient, right? 85 to 90% of energy is being converted into the electrical, right? So it was 90 to 85 to 90% efficient. So because of its high efficiency, it is being used more. Second, low maintenance. The maintenance of the BLDC's motors low compared to the PMSM and induction motor, right? Third, it will high torque to current ratio. What is high torque to current ratio? Even at low speed, even at lower current, it can give you the higher amount of torque even at the lower current itself. If your current rating of the particular vehicle is low, even at that small current rating, it can able to give you the higher amount of torque, right? That's why it has high torque to current ratio. It improves the reliability. That means we are not using brushes over here. That means efficiency increases, reliability increases. If we are going to use the brushes, ultimately after certain uses, we have to change the carbon brushes, right? So reliability will be less. Reliability means how much we can use that motors, right? So BLDC motors are majority being used in our homes fan, right? Like Atomberg fan, if you had heard about various other BLDC operated fans you heard about. Over there, the BLDC motor is being used. Over there, the connection of the Atomberg fan and all those connection will be different. They're not using any capacitors also. Guys, okay. So reliability will be high as well. So these are the advantages of the BLDC motor over other kind of motor. So what are the challenges and the disadvantages? First, the BLDC motor comes with higher cost. Why? They had electronic speed controller, they had Hall effect sensor embedded in it. That's why the BLDC motor come at the higher cost. You purchase the DC motor, if you purchase the BLDC motor, the cost will be too high of the BLDC motor. Then again, we have to design the ESC. ESC is nothing but a controller. So to operate the BLDC motor, we have to design the controller, right? Again, that is the complex algorithm. Then the peak torque given by the BLDC motor is very limited compared to the induction motor, compared to the PMSM motor. The torque provided by the BLDC motor is limited, right? Then dependence on the sensor system. If when the BLDC motor sensors damage, ultimately it will going to damage the complete BLDC motor. Why? Because if the sensors damage, they will not going to detect the rotor position. If they will not going to detect the rotor position, controller will not going to energize the coil. If controller won't able to energize the coil, the rotor won't rotate. Ultimately, your motor stops working. So these are some of the challenges, disadvantages, which is actually persisting in the BLDC motors design. So what is the role of the BLDC motor in the revolutionization of the electric vehicle? It made the electric vehicle highly efficient. because of not using any brushes. Because of its compact design, it can used widely in an electric vehicle. Because of its cost effectiveness, if I'm talking about outrunner motor, it is much cost effective. So we can directly embed that in the electric vehicles for the short term uses. So it is very cost effective in case of outrunner motor. Because of its cost effectiveness, it is revolutionized the use of the in electric vehicle. Because of its lower maintenance, the maintenance of the BLDC motor is generally lower, right? And hub motor application, what we had learned that outrunner motor, that is nothing but called as the hub motor, right? This motor, this motor is nothing but called as the hub motor only, right? We're going to read about in depth what is happening on this motors. We're going to happening on that motors. We're going to read about this all these things in the basic EV classes, right? Then if I'm talking about the last, which is the future trend of the electric vehicle motor, sorry for the mistyping over here. What are the future trend of the electric vehicle motor, right, of the BLDC motor? We are working on using the advanced material for the BLDC motor. Instead of neodymium, we can use some other, we can use the composite material like neodymium, iron, boron. You know, by this we can optimize or enhance the motor efficiency from 85 to 90% to 95 to 100%. Likewise, and we can reduce the size of the motor as well. Once the motor size is being reduced, ultimately we can use it, the higher efficiency motor, in an electric vehicle much more widely, right? Then we are actually integrating a lot of algorithms, lot of control algorithms inside the motor, like field oriented control, sensorless control algorithm, such that it can able to control the BLDC motor in an efficient way. So all this, how the FOC works, how the sensorless control algorithm works, we're going to understand it when we're going to understood the BLDC motor control algorithm in the EV classes, right? Then innovation in manufacturing and design, we want that the electric vehicle motor should be very much delicate in the design, should be very much compact in the design. Any doubts? What kind of motors are used in petroleum, diesel, fed vehicle? They are different motors. They are called starter motors, which is nothing but a switched reluctance motor, basically. Okay, starter motors, they are there to actually energize, actually to self-start your vehicle, right? To rotate the, flywheels of your engine to give him the initial torque. They're switched reluctance motor, basically. Okay, then again, the starter motor had a lot of things. Solenoid is being there. The complete design is a bit different. Getting Shad? So if I'm talking about innovation in manufacturing and design, we are actually using the BLDC motor such that we can make it more compact to be more used in the robotics and the drone. If it is being more compact, that means energy density will be high. It can give the more energy in smaller size. Then if energy density will be higher, ultimately it can be used widely in an electric vehicle, right? Then we want to reduce its cost and accessibility. We want to increase its accessibility. For cost reduction, we are using some composite material as well. Apart from that, we wanted to generate the controller in a lower cost as well. The controller technology, I think, has been going on so that we can reduce the cost of the BLDC motor, because BLDC motor cost is being incurred because of the permanent magnet and controller, basically. Okay, so that's why I told you that advance in the better material is going on, like neodymium, iron, boron. It will give you higher efficiency. Apart from that, we are not only using the neodymium, we are using some amount of iron, we are using some amount of boron, right? So neodymium perfectly is completely being used in the electric, in the motor. It will going to increase the cost. If some percentage of the initially let us suppose we are using 100% of neodymium, now we are using 50% neodymium, so the cost of 50% neodymium will be reduced, right? If the cost of 50% neodymium will be reduced, the rest 50% will be come from iron and boron, which is nominal in price. So by this way, we are actually decreasing the cost of the BLDC motor. In the future, it will be going to decrease further. So this is all about the complete BLDC brushless DC motor. A lot more to come when going to start the basics of EV classes. Thank you. That's all from my side.